Section 12.2. Now we're doing hypothesis for one population proportion. Before we did one population mean, here population proportion. So basically we need to run just some testing. This is called one proportion z-test. One proportion z-test, because we use the z-table and the z-test to run it. And to perform this, first thing is it has to be the simple random sampling. Both n p sub 0 and n times 1 minus p sub 0 both are greater than or equal to 5. When it comes to setting the null hypothesis, if you remember in the mean, when we had the mean, we set h0 to be mu equals mu 0, right? And ha or h1, mu either does not equal mu 0 or bigger than mu 0 or less than mu 0. Here instead of mu, we have p for population proportion, p. And so one of these tests is going to be either two-tailed test, left-tailed test, right-tailed test, as we did before. And to get compute the z-test statistic, I call it z sub 0. You do p hat minus p sub 0, where p hat is x over n, where you have to calculate most of the time, minus p sub 0, which will be given over the given information, the square root of p0 times 1 minus p0 over n, the sample size, over n, the sample size. And then we proceed exactly as we did in the previous sections. We find the critical value and see if z sub 0 falls in the critical region or not. If it is, we reject the null hypothesis, means there is a sufficient evidence to support the claim. And the other way is to find the p-value that a lot of students don't like to use. Find the p-value, and the p-value, I compare the p-value with alpha that will be given to us, and based on that we can tell if we need to reject the null hypothesis or not. Again, these graphs are the same almost to every single test we ran through so far, that the p-value represents the area to the right, to the left, or on both sides. The one on the left side, that's the critical value or the critical approach. If it's right-tailed to the right, left-tailed to the left, two-tailed both right and left. And the best thing we can do now is to look at an example. Look at an example, how we approach this. So we have an example here that says in early February 2013, and a survey was conducted of 1,015 U.S. adults that asked which country is the leading economic power in the world. Okay, and out of these, this is n, this is the sample size. Out of these 538 of them, they said China. So this is what is this 538? That's the x value. Okay, at the 5% level of confidence, so alpha is 0.05. Do the data provide sufficient evidence to conclude that at the time a majority means more than 50%? A majority means more than 50%. More than 50%. That's the P0. P0 is 0.50 or 50, which is 50%. More than 50% of U.S. adults consider China the leading economic power in the world. That's an interesting question, and based on this survey or statistical data, can we really conclude that this works for all the U.S. population or not? That's what we're going to do now. So to do that, we have the formula, the Z0 that we need to find here. But to find this one, we need P0, which we already have. We need P hat and N. N, we know the N is 1,015. From these two, we can find the P hat. It's X over N. 538 divided by 1015. And that gives us 0.530. That's P hat. So I have all the formula, all the stuff for the phone to find the Z sub 0. It's P hat minus P sub 0. The square root of P sub 0, 1 minus P sub 0 over N. P hat is 0.530 minus 0.50 over the square root of 0.50 times 1 minus 0.50, over n. N is 1015. If you put that in the calculator, that gives us 1.91. 1.91. That's Z sub 0. Now we have two different approaches as before. We have the critical value approach and the p-value. Let's take each one of them and find them. So for the critical value, how do we find the critical value? We have alpha equals 0.05. Okay, remember the Z table, table 2, or Z table. It gives us only to the left. Well, where's the null hypothesis? Oh, we don't set them up. This always be equal P0, which is 0.50, and it says the majority means more than 50%. So what we need to do here, more than, that's the right tail test. So this tells us it's a right tail test. Okay, and since it's a right tail test, what we need to do is the T table gives you only to the right. To the left, only to the left. So what we need to do always, we need to find 1 minus alpha, 1 minus 0.05, 0.95. So now what do we do in table 2? We go to the body of the table and find this in the body of the table. Body of the table. Okay, in the body of the table. And then what we need to do, as I'm looking at the table right now, I'm going to look at it right now. So in the body of the table, I'm going to find out 0.95. 0.95. There is no exactly 0.95, but there is 0.9505 and 0.94. So I see 0.94, 95, and 0.9505. So like this. This is 1.6. This is 0.04, 0.05. Okay, so that's what we have. In this case, what is the Z value, the critical value I'm looking for? Well, it's gonna go like this, 0.6, and somewhere in between here, right? In between, because that's where exactly that value is, 0.95. So what is this here? Well, this value here, this number, is the average of these two numbers. So if you average 0.04 plus 0.05 divided by 2, what does that give us? You know, you can try it, and we've worked with this this kind of calculation before, or this number exactly before. So if you do the calculation, you get 0.045. So then the Z value would be 45. That's the Z value. Okay, so now this means we are going to create the T table, the graph, and this is 1.645. But the Z sub 0, so just to make sure the area of this is 0.05, which is the alpha value. Now the Z0 we found was 1.9 something. So 1.9, it's, let's say, somewhere here, 1.91. Notice how Z0 falls in the rejection region. So we reject the null hypothesis. So we reject the null hypothesis. This means we are at the 5% level confidence. The data we have provides sufficient evidence to conclude that the majority of the U.S. adults consider China as the leading economics power in the world. That's what reject the null hypothesis means. You support the claim. Okay, you support the claim. Now for the p-value approach, so I'm gonna do it here. For the p-value approach, How are we going to find the p-value here? Well, we found z. Z was 1.91. We call it z sub 0, right? Z sub 0. We are going to see how to find the p-value. The p-value, again, it's the p-value is the area under the curve. So we need to look in the body of the table. So the p is when the z here was bigger than z0, but the table gives us 1 minus the probability z less than z0, right? It's only to the left. So 1 minus the probability that z is less than 1.91. So we need to go to the table and table 2 again, or the z table, and find out the z value 1.91. That gives me 0.9719. And then I just subtract that. So we subtract that, that gives me 0.0281. Then we compare the p-value. So this is the p-value and alpha. So notice that the p-value, which is 0.0281, is less than alpha, which is 0.05. So we reject the null hypothesis. Reject the null hypothesis. That's for one population proportion. And as you noticed, it was a right tail test. This example is a right tail test. Same thing can be done for left tail test and two tail test. The same procedure. If you want, we can take another example. Let's make it two tail tests. So let's say x is given to us as 16. The sample size is 20. H0 is set up to us p equals 0.7. HA is set up p does not equal 0.7. And alpha, let's keep it at 0.05. Okay, we're going to run the, first we find the sample proportion p hat is x over n. X is 16, n is 20. Divide that out, you get 0.80. Then decide whether using the one proportion z test is appropriate or not. Well, to do that, we need to find n times p0. N times p0 is 20 times 0.7. That's what p0 is. And that gives us 14. This should be bigger than or equal to 5. And also n times 1 minus p0. So n is 20 times 1 minus 0.7. That also 6. That's bigger than 5 or equal to 5. Since both of them are bigger than or equal to 5, so we can use the one proportion z-test. Use the one proportion t-test to perform the specified hypothesis test. We need to run the two tail tests here. So always find z sub 0. It's p hat minus p0 over the square root of p0 times 1 minus p0 over n. P hat is 0.8 minus p0 is 0.7 over 0.7 times 1 minus 0.7, and n is 20. If you put all this in the calculator, that gave me 0.98. Okay, now we can either use the p-value or the critical value. Let's use the critical value for now. Critical value. To do so, we need to go to the table, right? So for z, here is a two-tailed test. So we do the plus or minus z. Alpha is 0.5 over 2 plus or minus z sub 0.025. And if you look that up, that's plus or minus 1.96. Okay, plus or minus 0.96. So if you put that on the graph, this is 1.96 and this is negative 1.96. Now this plus this, that's each one is alpha over 2 area. What is the z0? It's 0.8 something here. It's not in the rejection region, so we do not reject the null hypothesis. We do not reject the null hypothesis. And the same thing for if you like to find a p-value, or if you like to use it for the right tail test, left tail test, the same procedure as before.